Hello everyone and welcome to another video on our own devices. I'm Jean Messier and today we're having a look at a device that you've probably seen in dozens of movies, cartoons, and other media, or may even have used yourself on a regular basis. This is a Simplex Model TCF electric time recorder, also commonly known as a time clock, punch clock, clock card machine, or if you're Australian, a Bundy. And this type of device was designed to allow employers to keep track of the hours worked by their employees, especially if a workplace operated on a flexible schedule rather than fixed shifts. Now, the basic operation of one of these machines is very simple. As an employee, you're given an individual time card, and at the start of your shift, you simply insert the card into the machine as so, press this bar, and the machine stamps the month, day, and time onto the card. You repeat this process at the end of your shift, and then after a certain number of days, a payroll clerk collects everybody's cards and uses them to calculate the hours worked by every employee over a certain pay period. Now, while externally this machine is very simple, inside the case there are a lot of really interesting things going on, and the some 100-year development history of traditional punch clock machines is absolutely fascinating. So let's have a closer look at this machine. Let me show you where it came from and how it works. But before we do that, let's have a quick word from this video sponsor, Hungry Minds. Now, if the apocalypse were to go down tomorrow and you were faced with the daunting task of rebuilding civilization from scratch, time recorders would probably not be high on your list of priorities. There'd be many, many more vital technologies to reestablish first. But which technologies, and where would you get the information you needed to get started? Well, in here, the book, aka the last book, The Ultimate Guide to Rebuilding Civilization. So I'd actually heard about this book before Hungry Minds contacted me, but I really wasn't prepared for how cool this is. This is an absolutely gorgeous hardbound compendium of all manner of technologies and techniques that underpin a modern functioning society. 400 pages and 23 chapters covering everything from agriculture and cooking to road and bridge building, metal smelting, medicine, weaponry, and even aviation and space travel. And all this is conveyed through absolutely phenomenal drawings that I can only describe as a combination of engineering drawings and sketches from a Leonardo da Vinci sketchbook. The illustrations are also peppered with fun little visual gags, meaning every time I flip through, I always spot something new. In fact, this really reminds me of Stephen Bisty's Cross Sections book, which I absolutely adored as a child and still do. Better still, all the technical information is correct and very useful, the book having been put together by an international team of artists, engineers, scientists, architects, and designers. Even I learned a thing or two just flipping through it. You can be sure that this is going to inspire quite a few future videos. Now, you know me, I'm very particular about the brands that I will represent on this channel, so it's really quite rare for me to get this excited about a sponsorship deal. And if you want a copy of this book for your own library, just follow the link in the description below or the QR code on the screen right now and enter the promo code OurOwnDevices10 to get 10% off your purchase. So thank you so much to Hungry Minds for sponsoring this video, and back to time recorders. Now, the first time recorders were invented around the mid-19th century, with inventors coming up with all sorts of interesting mechanisms to accomplish this seemingly simple task. For example, one of the very first models, patented in 1855 by British inventor John Adams, no, not that John Adams, featured an internal vertically mounted drum with slots around its circumference driven by a clock mechanism. Each employee was given a numbered metal token, which they dropped into the machine at the start of their shift. An internal chute conveyed the token to the slot on the rotating drum corresponding to that particular time. After all employees had arrived, the payroll clerk would open the machine and match each token with the slot in which it was deposited to figure out each employee's clock-in time. This procedure would then be repeated at end of shift in order to determine clock-out time. However, drum-type machines were very cumbersome to use and were never really popular, and so they were soon replaced by dial-type recorders, first patented by Scottish inventor Alexander Day in 1888. This incorporated an internal paper roll and a large circular dial with equally spaced numbered holes, each corresponding to a different employee. On starting their shift, an employee took the pointer on the centrally pivoted arm and placed it in their particular hole, causing the internal clock mechanism to print their employee number and clock-in time on the paper roll. A similar device invented a few decades later was the button-type time recorder, which only required the employee to push a button corresponding to their employee number. However, these machines were inherently limited since the larger a company's workforce, the larger and heavier the machine had to be. A slightly more efficient system was the autograph recorder, patented by American inventor Charles Van Voorhis in 1888. This featured a small window that allowed each employee to sign their name on the internal paper roll before pulling a handle, which drew the paper into the machine and printed the timestamp beside the signature. But while the system was not limited by the size of the workforce, as in previous machines, each employee's clock in and clock out time would be recorded at different points on the paper roll, meaning a payroll clerk would have to spend a significant amount of time hunting down and matching up the appropriate pairs of timestamps. Hardly the most efficient system. Now, 1886 was apparently a banner year for inventors of time recorders because one of the first truly successful designs was also patented in that year by William Bundy, a jeweler from Auburn, New York. The Bundy clock was something of a hybrid between the drum and the dial clock. Each employee was given a special key numbered 0 to 99, which, when inserted into the machine and turned, caused the key number and the timestamp to be printed on the internal paper roll. The following year, Willard Bundy and his brother Harlow incorporated the Bundy Manufacturing Company in Binghamton, New York. This business was extremely successful, selling thousands of time recorders all around the world. Indeed, the brand became so ubiquitous that in many places, particularly Australia, time recorders are still colloquially known as Bundys. Finally, in 1894, American inventor Daniel M. Cooper patented the most recognizable form of time recorder, the card type. Each employee was given an individual time card, which was stored in a rack beside the time recorder and inserted into the machine and stamped at the start and finish of their shift. This is a much more flexible and efficient system and became the de facto time recorder design throughout the 20th century. A later refinement to this system was the card clip recorder, which used an internal punch to cut out a notch from the corner of the card, meaning that every time it was inserted, the print head would align with the next line, preventing timestamps from being overprinted. And as another aside, a similar system known as a watch clock was, and still is, widely used to keep track of security guard patrols. Either the guard carries a portable locked recording clock and there are different keys chained to the wall at different points along their route, or vice versa. Either way, the guard has to check in at each station by turning a key in the clock, which records the time that the key was turned. And this is to prevent the guard from lazing about in one spot or falling asleep on the job. Now, while in the late 19th century there were dozens of different time recorder companies, going into the 20th, the market underwent a great deal of consolidation. For example, in 1900, the Bundy Manufacturing Company acquired two competing time recorder manufacturers, the Chicago Time Register Company and the Willard and Frick Manufacturing Company, and reincorporated as the International Time Recording Company, or ITR. In 1906, ITR relocated to Endicott, New York, and in 1908 acquired the Syracuse Time Recorder Company. Finally, in 1911, ITR was acquired by the Computing Tabulating Recording Company, or CTR, which 6 years later changed its name to the far more familiar International Business Machines, aka IBM. And if you want to learn more about the early history of IBM and punch card computing, please check out my previous videos on the business forms ruler, as well as this video I wrote on the company's dark past over on Today I Found Out. Links in the description. This particular example, a model TCF or Tombstone electric time recorder, was manufactured by the Simplex Recorder Company, founded by one Edward G. Watkins in 1894 in Gardner, Massachusetts. In addition to time recorders, Watkins also developed and sold some of the first successful synchronized master-slave clock systems of the type commonly found in schools and large office buildings. In 1958, Simplex acquired IBM's Time Equipment and Fire Protection divisions and began selling former IBM time recorders, fire alarms, and other equipment under their own brand name. In 2001, they merged with the Grinnell Fire Protection Company, founded in 1892 by Frederick Grinnell and one of the first companies to sell a modern fire sprinkler system for buildings, to form Simplex Grinnell, now a division of Johnson Controls. Whew. So with all of that history out of the way, let's finally have a look at this example and let me show you how it works. Now, unfortunately, I haven't been able to find out when this particular unit was manufactured, though I did find out that the TCF was introduced in 1931, and then in 1940, Simplex began adding a letter suffix to the serial number to indicate the year of manufacture. As the serial number of this unit, 80255, lacks such a suffix, that likely means it was manufactured sometime between 1931 and 1940. But as always, if any of you know more about this subject, please let me know and I will add that additional information to the description of this video. Now, externally, there are very few features or controls on this time recorder. On the back, we have a power cord and 3 holes for mounting the case on a wall. while on the front we have the clock face, a slot for the time cards, a large stamping switch or bar, and a lock to prevent employees from tampering with the mechanism. And as I showed you at the start of the video, to use this machine you just insert your time card into the slot and press the bar to stamp the time code. And handily, there is enough ink left in the ribbon that this example still works perfectly. Now, unfortunately, there are no guides or clipping stamps or any other mechanism to help align the cards, so in order to prevent overstamping, you have to align the next line with this notch in the middle of the case. Now, this example did not come with its original key, but thankfully it was already unlocked, so we can just pull off the front of the case as so. Now, at first glance, the internals look very complex, but in reality, this mechanism is relatively straightforward. Starting at the back, the clockwork is driven by what is called a Telechron, a self-starting synchronous motor whose rate of rotation is directly proportional to the frequency of the alternating current supplied to it. This type of motor was first patented in 1918 by American inventor Henry E. Warren, who had founded the Telechron Company 6 years before to manufacture and sell battery-operated clocks. Those clocks, however, tended to run down quickly and didn't sell very well. But a clock running on an AC Telechron motor could be operated and regulated continuously using regular mains power. Problem was, this required the power grid to run at a consistent frequency, and with dozens of different power companies operating grids all across the continent, this simply wasn't possible. And so Warren invented what was known as a master clock, incorporating both a Telechron-powered electric clock and a traditional mechanical pendulum clock, which was adjusted twice daily according to time signals received from the U.S. Naval Observatory in Washington, D.C. So long as the electric and mechanical clocks kept the same time, the grid was operating at the correct frequency, typically 60 Hz. If, however, the electric clock began running fast or slow, then the power company could adjust the speed of its generators in order to bring both clocks back into sync. Now, the first Warren master clock was installed at the Boston Edison Company generating station in 1916, and by 1947, nearly 95% of power grids across the United States were being regulated by these clocks. Now, the Telechron Company also sold millions of ordinary electric clocks to consumers all the way until 1991, when the company finally went under. And by this time, electric clocks had largely been supplanted by quartz movements, which were even more accurate and could run for long periods of time on batteries. Anyway, getting back to this time recorder, as you can see here, the Telechron motor drives a rotating cam which, every minute, strikes this pawl and increments the stamping mechanism. This consists of 4 horizontally mounted coaxial tape discs for stamping, left to right, the hour, the minute, the month, and the day. Interestingly, the hour disc is divided into 2 sets of 12 hours, with the hours between noon and midnight indicated by underlined numbers. Now, each time the minute disc increments, it pushes this spring-loaded pawl further and further outwards until it completes a full rotation of 60 minutes, whereupon the pawl snaps back and increments the hour disc by 1 position. Similarly, when the hour disc completes a full rotation of 24 hours, it increments the day disc by 1 position. Finally, the day disc includes 31 standard days, meaning that if a month has 30, 29, or 28 days, then the machine needs to be adjusted manually. And by the way, to set the proper day, time, and month, you simply disengage either this, or this lever and rotate the corresponding disc to the appropriate position. Overall, this system is very similar to many of the mechanical calculators that I previously covered on this channel. Links in the description. And finally, the last interesting part of this mechanism is the stamping system. As you can see, this uses a typewriter-style ribbon held on these 2 spools, and which lays across this sheet metal platen beneath the type discs. There is an opening in the center of this platen, beneath which is this hammer connected to this solenoid on the left side of the machine. When you push the bar in the front, it closes this switch, which activates the solenoid and swings the hammer upward, driving the time card into the ribbon and type disc and printing the timestamp onto the card. And that, dear viewers, is a brief overview of time recorder or punch clocks. Now, I, like you, have seen these in a ton of movies and other media and often wondered exactly how they work, so it's a lot of fun to be able to take this one apart and have a look at the inner workings. So I hope you found that interesting. Thank you so much for watching, and thank you to Hungry Minds for sponsoring this video. I'll see you next time in another video where we'll look at yet more timekeeping and other fascinating devices just like this one. Until then, I'm Messier from Our Own Devices. Have a great day.